Yeah, let them just say, they just say she never mind the live streaming. That's all. Let me just check, but you may have to link your phone WhatsApp to the web, to the WhatsApp web on the laptop. No, I'm using the desktop. That's the problem. Yeah, but let me see if the link is there. Yeah, but yeah, just send that message immediately. Yeah, they can just log into that. Everybody can live streaming. It will come. That's how I've been doing it. Yeah.
No, you can check your WhatsApp. You can try it before you send it. Now have you sent the message already? Okay, that's fine then.
And I'm going to forward this.
Okay.
In the main group, I'm not able to send anything. Let me
You can. I've seen there are few students that have joined. Yeah, I think about 3 or so. Students, kindly confirm if you are able to get me. Just type yes. Those that have joined, just confirm and type yes if you are able to get me, please. Christopher, are you able to get me? Just type yes if you are able to get what I'm saying. All right, if for those that have just joined, if you are able to get what I'm saying, just type yes so that we can start our class. Okay, I think as we wait for others, we can start. If you are able to get what I'm saying, kindly type yes.
No, you're yes. Can I put it in your
All right, we are going to start as others will join, of course. So we don't need to wait for. We have already wasted so much time in trying to connect. The connectivity was not too well in school this morning. Yeah, first of all, I'll try to remind you of what you last did. Of course, you were looking at wake, energy, and power. So today we are going to move on, but before we move on, I would like to remind you of what you actually looked at when you had looked at work, energy, and power. Of course, you had defined work to be equal to, of course, this is the F multiplied by the distance. Then you also defined energy as the ability to do work. This is the ability to do work. And of course, power, you defined it as the rate at which work is done. That is how you define these three terms. So work, energy, and power, they are so closely related. So here you said power is equal to work over what? Over time. As simple as that. So the change, that is the same as the change in the kinetic energy divided by the change in time, which you can still write as the change in the work done over the change in time. I think this is what you had learned last week. Now, there's also, of course, another form of power which you had defined to say power can also be defined in an event that we don't have other parameters. You say power can also be defined as F multiplied by V. So in case the other parameters are missing in the question that you've been given, you realize that you can easily use either this equation of power or this other one, which is here. And then you also defined, of course, the potential energy, which you said the potential energy was nothing to you but the mgh. This is straight away from high school. And then you defined the kinetic energy to be equal to half mv squared. So of course, we know that energy can neither be what? Created nor destroyed, but it can only change either from the potential energy, where we have a stationary body, or to a kinetic energy where we have a moving body in that way. So this is how you have defined some of the parameters when you looked at work, energy, and power. And today we want to move on to what is called momentum and collisions. But before I do that, I would wish to mention that for those that had not written the test 1, the makeup will be done today and tomorrow. And also the test 2 will come the week after next week. So that is when you'll be writing your test 2. You have to get prepared for that. We'll send the timetable. Of course, by the end of today or tomorrow, you'll receive the timetable for test 2 as you prepare for your exams. So the test 2 will be entirely online. There's nothing like you coming back to school or coming to sit for them. They will be given to you online. And of course, exams will be physical. You shouldn't misquote me to say the exams will be online. So we want to continue today to look at another very important topic, which is momentum and collisions. These things, of course, we have heard about them, and it's not the first time that we are seeing such technologies. We're just trying to reintroduce what we know, but in another form, of course, in a little bit more advanced form. Now, I've said we are going to look at momentum and collisions. Okay, momentum and collisions. Now, first of all, we see to it that there are 2 terms in our subject for today. And the first one is what we call the momentum. We want to know what is this momentum that we are talking about. And of course, after we have defined what momentum is, this we just need to remind ourselves. We don't need to, to define what a collision is. Of course, we know very well. Let me just check, since there's someone who is typing. Okay, ODL, you are going to access the test, of course, online as usual. There's all the tests for you will be online. I've seen the text there and I was just trying to answer to that. Okay, now, momentum and collisions. First of all, let's define what momentum is. momentum in physics and in simple terms is defined as mv. In other words, we are saying this momentum, which we normally abbreviate as small p with a vector symbol on top, is defined as the mass multiplied by the velocity of a given body. So here we are saying this is the mass, that is the velocity, and this gives us the momentum in that way. Now, how we define the momentum, we see to it that momentum is actually direct proportional to the velocity of a given body. Of course, we know that this mass is a constant. That means the higher the velocity, the higher the momentum. In other words, a body that is moving at a higher velocity has what is called high momentum. So we know that momentum is defined as the product between the mass of a given body and the velocity of that given body. So now we know, going back to Newton's second law, what we see is that we know for sure that from Newton's second law, what we see is that the F, which is capital F, let me put it this side so that you'll be able to see well. That is, F is defined as mass multiplied by the change in the velocity over the change in time. We know for sure that this is nothing but the acceleration, which is a. That is why we have ma. And a, we know for sure that acceleration is equal to the change in velocity over the change in time, which is the same as the first derivative of the velocity with respect to time. Now, in this case, we see that, but we are saying, but momentum is defined as mv. That is how we define it. So if we see to it that this F, which is equal to m, then change in v over change in time, we see that the mv, which is this one here, is nothing but the momentum. That means this F can be defined as the change in momentum over the change in time. Please take note of this very important formula. F is equal to the change in momentum over the change in time. And at times, students would ask, when given a question, to say, there is no, in the question, there's only mass, or you have been given the momentum. Then you are asked maybe to find the time. Most students will forget this very simple equation here, which you can easily derive. You have from second law, F is equal to ma, then A, you redefine it as the change in V over the change in T, which of course mv gives you P. Then in that way, we know that F becomes the change in momentum over the change in time. So straight away, you'll be able to see the relationship there. If we can continue from there, I think that is simple and straightforward. We look at the second part, which is called conservation of momentum. How do we conserve momentum? Okay. Just Just like we mentioned in terms of energy, we know for sure that we have mentioned that energy can neither be created nor destroyed, but can only be changed from one form to the other, of course. So here we are saying conservation of momentum. In here, what we need to note is the following. We are saying the first thing we need to note here, which is very important, is that momentum before collision is equal to, you underline the word equal to, is equal to momentum after collision. This is very important. In other words, the momentum, of course, we have, say, this is a particle 1, and of course, we have another particle here, which we are calling particle 2. This is moving in this direction. This is moving in that direction. When they collide at that point, this becomes P1 prime, P2 prime. Then, of course, maybe they may be going in that direction, where you have P1 prime, P2 prime. So this becomes our system A, and after collision, this becomes our system B. So what this means is that momentum, which we are saying P at point A must be equal to momentum at point B. So this is very important. So whenever we have a collision, we have to put in mind that there is what is called conservation of momentum, where momentum before collision must be equal to momentum after collision. I hope it is clear and you are able to get the concepts. So we move on to the same, but just a little bit more mathematical, just to try and explain what that sentence means in a mathematical form. Okay. All right. So we shall explain this concept by using the third law of motion. Which, of course, we mentioned when we were still here. We had mentioned, we discussed about this, where we had said, of course, for every action, there is an equal but opposite reaction. That is according to